All right, so we're going to start now our next section of this unit. So we're going through the metric system. We've already talked about length, area, volume. Now we're moving on to mass. So mass is a term which means the amount of matter there is in an object. Amount of matter in an object. Think of it as sort of how much stuff is packed in there. So if I have these two cubes here, I'll pass them around. How do you think their volume compares? Pretty close. Or just about exactly the same. But when I pass them around, what you'll notice is that their mass is much different. You can pass those around. Even though they take up the same amount of space, their mass is different. Why is their mass different? What's different about those things? Catherine? The type of atoms. And also, well, yeah, heavier in mass, we sort of use those words sort of connected. They're more densely. The molecules are more densely packed in the cube of metal versus the wooden cube. There's more molecules packed into the same volume, giving it a greater mass. Now, when we talk about mass, we have this concept, and it applies to energy as well as mass. It's called the law of conservation. And this law of conservation says that matter cannot be created, it cannot be destroyed, it can only change form. So, if I take a piece of paper, for example, and I burn it, am I destroying the matter? But it's gone, right? That's right, it's changed. It's not gone. I didn't destroy the matter that made up that paper, but I've transformed it. What does it turn into? Ash. What else? What? Smoke. Some water, some carbon dioxide, some carbon monoxide, and other chemicals. So I'm changing that matter from one form into another. Okay? I'm not actually destroying it. So matter cannot be created, cannot be destroyed, but it can be transformed from one form into another. Ian?
But on the theory that matter cannot be created, what if what about if a chicken lays an egg and then that egg gets to be a dark chicken, or like you plant a sapling?
Again, it's just molecules being transformed, where molecules are coming from food, being incorporated into that growing tissue. So it's still the same matter, it's just being changed in form. The units we use for mass, the base units in the metric system, are grams. The most commonly used units are milligrams for small quantities, kilograms for larger quantities. A kilogram is about 2.2 pounds. Right? So 1 kilogram is about 2.2 pounds. A gram is about the mass of maybe the cap of a pen. Would be about a gram. And a milligram is a small unit. Obviously, there's 1,000 milligrams in a gram. Where many of you have heard milligrams used commonly? Catherine? Medicine, vitamins, you may take 200 milligrams of Advil. Or you may need 100 milligrams of a certain vitamin in your diet daily. So milligrams generally used for small amounts. The tools we use for measuring mass is generally a balance. We're going to use two different types of balances in class. This one is called a triple beam balance I have up here. So this is a triple beam balance. Okay, when you look at the parts, we have the pan where you place your object. Okay? Generally, when you're measuring something, you want to place your object in the center of the pan. We have the riders, which are these beams that have numbered scale and they have a weight on each one. We also have a knob over here, a zero knob. Okay? What you do is before you are going to measure an object, you want to make sure that your balance is zero, which means with nothing on the pan and all of your weights at zero, this pointer should line up exactly at the zero mark. This one's a little off. The pointer is a little above the zero mark. So I rotate this zero knob a little bit to adjust that. That helps to calibrate this balance and make sure, okay, it's just about perfect. So now the pointer is right at zero when there's nothing on there. That's good. So when I put an object on there, I'm going to get an accurate measurement of its mass. Okay? So what I do is I slide all the riders to zero, make sure the pointer is swinging freely. I adjust the zero knob if necessary. And once you do that once, you generally are not going to need to do it very much. Put my object on the pan, and then I slide these weights until it balances back at zero again. It's just like you go to the doctor's office, if they have one of those old style weight scales where they slide the metal weights till it balances. It's the same idea. So I could start with the biggest one. Okay. Now what happens if it goes all the way down? What do I have to do?
Move it back to the left.
Yeah, move it back again. So, okay. Then I'll go to the next largest rider and start moving that up. So if it goes all the way to the bottom, I need to go back one. And then I'll go with the smallest one. This one, the largest rider and the second largest one, they have notches. And the rider has to be in a notch in order for this to work, you'll see. But this last one just slides freely up and down. And so again, I move that one until this balances out at zero. And then I can read. For example, for this one, I have the largest rider is at 100. The back one is at 40. And then this one is at 7.4. So you add them all up, and that's the mass of your object, 147.4 grams. That's how we use this triple beam balance. All right. We also have an electronic balance, a digital balance that we sometimes will use. Okay, this is a digital balance. And again, it works kind of like a bathroom scale or something. You turn it on. It reads zero right now. Okay. If it says something other than zero, you're going to just press zero and that'll reset it. Okay. You want it to read zero when there's nothing on the pan. Put your object on there and read the mass. This is 30.2 grams. Now, the digital balance is helpful because if I want to measure, let's say, the mass of this much water, how would I do that? How would I measure the mass of this water? Is this good? 193.4. Is that the mass of the water? Why not? Why not?
Because it's also taking the weight of the beaker.
Yeah, it's taking up the weight of the container as well. So what do I have to do?
You have to measure the mass of the beaker first and then subtract that.
Yes. That's one way I could do it. I could find the mass of the container, then add my liquid, then find the mass again and subtract to tell me the mass of just the liquid. But with the digital balance, that makes it easy because I could put my container on here. It's 80.2. But now if I press the zero button, this is going to reset to zero. Now it says zero. And now when I add this water, what am I going to get? Now is it giving me just the mass of the water? Yes. 144.9. Okay? So that's one of the nice things about the digital balance. If you're measuring a liquid, or even if you have a solid and you need a container to hold it, You can put your container on there, zero it, then add your material, and that'll give you the mass of just the material. What do you think this is gonna read when I take this off?
The same thing.
Nope. Nope, doesn't read zero.
The mass of the container.
Not quite, but close.
Negative.
Yes, negative 80.2 it says. Because the mass of the container was 80.2. All right. So that's how we measure mass. The parts, basically the pan, the zero button, and then the display. So if I'm looking at a balance, a triple beam balance, and I see the rider set up in this way, what is the mass of the object in this case? What's the mass? Look up here. Yours may have printed off a little bit. Look up here and tell me. Moya? 176? No?
75.
Yes. 175. How about this one? Okay,
128 grams.
328 grams.